Hi everyone, I want to thank you for inviting me to present my work on the social and institutional dimensions of urban electrification, with an emphasis at the intersection of electric mobility, energy equity, and urban planning. My name is Patricia Romero Lancao, and I'm a senior research scientist at the National Renewable Energy Lab with a joint appointment at the Mansueto Institute for Urban Innovations. I do research on justice in climate action and urban transitions of energy systems, mobility, and the built environment. I currently lead research integrating what we call equity analytics with modeling efforts, and I co-lead the SEGI initiative on the integration of electric transportation with the built environment and a clean grid. I also co-lead the study, the LA 100 equity study. Today, I will center my presentation on the decarbonization challenge, how urban electrification has the potential to address this challenge. I will define what urban electrification is. I also will briefly describe current urban electricity systems, and then I will present key shifts in trends and actions that are moving our electricity systems away from carbon. I will briefly describe some work on the benefits, options, and barriers to urban electrification. And I will center at the end on one of those related to how we can address issues of equity and enhance justice in urban electrification. According to the Intergovernmental Panel for Climate Change, the world is faced with a huge decarbonization challenge. For the world to stay within a 1.5 to centigrade increase in average global temperature, the economy in all countries needs to be decarbonized. Energy efficiency, fuel switching, particularly in the transportation sector, but also in the electricity sector, and human and social behavior need to shift across the board. They need to shift across transportation, buildings, and the grid. What is more important, renewable needs to supply between 70 and 85% of electricity systems. If we don't do so, we will continue to shift to externalize problems of air pollution and health to the areas and the regions providing electricity to cities and to urbanizing regions. The good news is that urban electrification offers the potential to decarbonize transportation, to decarbonize buildings, and to connect these two important systems and sectors to clean grids. There are several reasons why cities and the regions are becoming key players in the arena of climate change and also in the arena of decarbonization. Cities, first of all, are key sources of carbon and air pollution, emissions and air pollution. Cities are also hubs of development. They generate around 80% of the GDP. They consume about 75% of the global primary energy, and they emit over 70% of the energy-related greenhouse gases, which we measure using CO2 equivalents. Cities are not only source of the problem, cities are also source of the solutions. City actors of all sorts, including corporations, city officials, community organizations, NGOs, are promoting in technological and community innovations and narratives. They are developing programs, standards that are allowing cities to shift away from carbon and into cleaner energy systems. That says cities are also hotspots of climate risks. Cities and the regions are vulnerable to heat waves, wildfires, and hurricanes, which climate change is already aggravating, as can be seen in many parts of the world whenever they are confronted with the impacts of these events. It is expected that further electrification will alter those vulnerabilities in complex ways, and it is the role of many of you here and of us to understand and to manage those risks. Cities also can advance all these decarbonization goals while at the same time advancing and promoting the Sustainable Development Goals, in particular, goal number 7 on affordable, reliable, and sustainable energy, and goal number 13 on climate action and inclusive urban resilience. What is urban electrification? Urban electrification is the process of providing populations and economic activities, particularly more than 1 billion people currently lacking it, with modern types of electricity. Most recently, and through a series of technological and market innovations, electrification has become to be related to the increased use of electricity as an alternative fuel for transportation and for buildings, and to the coupling of built environment designs, for instance, those needed to charge electric vehicles, with and also to deal with the digitalization of our economy with clear electricity provision systems. Most importantly, and this is really relevant for many areas of Asia, Latin America, and Africa, is the fact that for cities that have not previously been fully electrified, for cities that have not been able to provide their poor populations with electricity, the possibility exists for these cities and regions to leapfrog. This means to skip altogether the use of fossil fuel-based generation and to directly adopt sustainably powered and resilient electricity sources. To harness the potential of urban electrification, it is important to understand that it is a multi-scale and a multi-sectoral process. As you can see in this figure that we included in a publication that I hope Sanjini can share with you, urban electrification and also urban electricity systems entail the distribution and use of electricity within a city. You can see it here in these little blue and green areas of the figure. But it does not only involve the distribution and use within a city, but also the provision by outside grids and distribution networks that are mostly located in rural areas and in some cases are located in other countries. This means that for us to manage electricity systems, we need to involve decision making and management across jurisdiction, from the local to the national and sometimes international levels, and across sectors. This creates lots of opportunities because it allows cities to be operated 24/7 hours during 7 days or 24/7, but it also creates problems of fit and externalities to outside areas that need to provide cities and regions and urbanizing regions with electricity. As I was saying from the beginning of this presentation, current electricity systems are undergoing deep transformations. To understand this, it is important to also understand how current electricity systems operate. We know that most of them are centrally operated by big grids that then distribute electricity to different areas of a country. This process is changing, is shifting from centralized systems to decentralized energy resources, also called DERs. Currently, electricity systems are experiencing deep changes globally. For instance, global electricity consumption has risen by 70% since 2000, and this has led electricity to become the second largest energy source by end use after oil. When we consider, you can see here on the left side the distribution of energy demand across key countries and regions. You see the importance that China, the important role as a source of energy demand that China is playing. You also see that the demand by United States and the European Union is more or less steady. When we consider the demand of electricity by sectors, we also find, and this is something you can see also in the paper I referred to, that light and heavy industry are the main source of electricity demand in developing countries, and that in advanced economies, the main source of electricity demand is the building sector. This is starting to change as we speak, because the transport share, which is currently one of the lowest shares, is projected to increase in the near future. Perhaps because of the centralized nature of electricity systems globally, estimations of urban consumption of electricity are limited by lack of data. Notwithstanding this, we were able to find that electrification varies across countries and from urban to rural areas, affecting energy supply and social practices of energy use differently. You can see here in this figure from another paper that associations, which a paper we cite in the paper I referred to, you can see here that associations between logarithmic GDP per capita and urban-rural total electrification rates vary across regions of the world, with North America and Europe to have highest levels of electrification among their urban and rural populations. Also, access to electricity in the US and Europe is nearly universal. That's not the case with other regions of the world, particularly the sub-Saharan Africa, where access to electricity is a concern. And it is a concern because electrification has been associated, as you can see in this figure, not only with GDP, but also with productivity and with quality of life. A series of global trends are placing cities and electricity at the vanguard of a far-reaching energy transition. I am here summarizing and referring to 4 of these key trends. For once, the world is witnessing growth in the production and use of clean technologies such as wind and solar. Climate change is also posing challenges and offering opportunities to decarbonize the economy and particularly the transportation sector. Of equal importance is the electrification of end uses and of technologies such as vehicles, some pumps that are used to heat the houses, stoves, and other appliances that users use. Visions about the future and about what cities can become are also playing a key role. Ideas such as the idea of a smart city or of a resilient city or a hub, of economic hub, are playing a role in organizing the efforts and the expectations of key city officials and private sector representatives and NGOs. All these processes are reconfiguring the structure and the functioning of not only electricity production but also electricity use. Interestingly, the already referred global trends are offering opportunities to engage in actions that address challenges, the climate change challenges I already referred to. All these global trends and challenges can be harnessed to optimize the decarbonization of transport, buildings, and the grid. For instance, the world expects an expansion of electric vehicles, which since 2010, together with chargers, grew to 7.2 and 7.3 million. Equally important is the fact that the cost of a battery decreased by 85%. The building sector or the built environment sector is also experiencing profound changes, given by a shift to grid iterative or interactive, electrified, connected and resilient communities of buildings, also districts, through the deployment of distributed energy resources. As I already had told you, there is a shift from centralized to decentralized systems. The power sector is also witnessing big changes, given by the shift to distributed systems powered by renewables and driven by the electrification of end uses I already referred to. The changes, the shifts in these key 3 sectors are also being driven by 2 cross-cutting trends. For once, the pandemic, COVID-19, has presented challenges, but is also offering opportunities to rebuild the economy and to create synergies between carbon-free mobility, building and grid systems. It also offers opportunities to create new and different jobs and to enhance the productivity of the economy. Policies and policy making are playing a key role in these processes. And here we are talking not only about policy actions by city officials, but also by NGOs, by community organizations, and by the private sector. All these sectors are working on developing incentives, standards, regulations that allow these technological innovations to fall in the right place and to be optimized for to enhance the productivity of the economy and also the equity of the countries where all these processes are taking place. Efforts to electrify transportation and integrate electric vehicles with buildings connected to clean grids are often associated with economic, societal, and environmental benefits, such as improvements in people's quality of life and health. Climate and atmospheric benefits can accrue via the electrification of transport and buildings, with additional benefits for fuel costs and human health. However, these benefits are variable depending on factors such as the generation mix of the electricity grid. The equity impacts of electrification, which I mark in this table in red, are also variable depending on the policies used to promote the transition. The nature and location of energy financing and infrastructure investments can cause low-income households to benefit or lose. For example, few low-income households participate in electric vehicle charging, storage, and solar programs. While such inequitable impacts of electricity tariffs can be offset by modest low-income energy assistance programs or subsidized EV access, which we are already identifying in LA, in Europe, and in other countries. Such support is widely variable depending on city, state, and utility provider. Another challenge is the general formulation of energy innovation policies through markets and incentivation, both of which create obstacles against adoption of new technologies by low-income populations. User perceptions and culture, as manifested in lack of familiarity with emerging technologies such as EVs, cultural and status expectations of comforts, anxiety and distrust, or just lack of knowledge, can become crucial sources of social barriers. For instance, even as the cost of electric vehicles becomes a less relevant concern, customers still experience worry about depleting their batteries charged before reaching their destination or waiting for the EVs to charge. I am here summarizing some of these benefits, options, and barriers to urban electrification, but I also would like to briefly refer to some of the technical and policy challenges. Substantial technical challenges are related to the provision of electricity through renewables and include the need to grow low-carbon energy storage capabilities, to develop new demand management capabilities, and to create distribution infrastructure able to deal with variations in power demand loads associated with changes in the use of electric vehicles and in behavior. Each of these developments can help mitigate mismatches in the spatial and temporal patterns of supply and demand of zero-carbon energy generation. These mismatches have beset the electrical industry since its very beginning and have historically been addressed using stored energy in the form of hydrocarbon fuels. The problem now is how to create future strategies that are likely to depend on multiple technologies, including distributed energy generation and storage, flexible low-carbon fuels such as hydrogen, renewables, grid-scale storage, and new transmission corridors. Urban form or the morphology of cities can also pose barriers such as inadequate charging infrastructure and PV installation, historical zone codes that prohibit the use or make harder the use of charging space. Policies also pose barriers. We know that in some countries, policy supports for electric vehicles and charging, such as regulations, incentives, and investments, can be removed, weakened, or just inadequate. For decades, transportation planning and policy has focused on optimizing the performance and efficiency of the transport system. This focus on the technical aspects of improvement fails to account for the real-world human impact. This has had deep consequences on justice, as some populations have enjoyed the fruits of the improving system, while others have been excluded from the benefits, experienced negative externalities, face health risks, or receive reduced mobility and accessibility. It is important at the outset to differentiate equity and justice. Equity refers to being fair and impartial. It engages with an organization or system, particularly a system of grievancy. Equity is often conflated with the term equality, as you can see in this cartoon. Equality meaning everyone has the same options. But in fact, true equity implies that an individual or group may need to experience or receive something different, not equal, to facilitate fairness and access. For example, a person with a wheelchair may need differential access to transportation services relative to someone else. To engage in the decarbonization of the transport system, the Biden administration and also many entities within the US are engaging with efforts to address social equity in the decarbonization projects. And for that purpose, it is important to distinguish three uses of equity in transportation projects. For one, it can be a conceptual tool where we need to consider the cultural and institutional aspects of a transportation system in a country, which vary and are very different when we go from Mexico to Vietnam or to India. Social equity can also be used as an analytical tool to understand how values are embedded into energy and transportation systems, and to resolve common transportation and energy problems. Most importantly, or equally important, is the fact that social equity can be used as a decision-making tool to assist planners and consumers in making more informed energy and transportation choices. Here you see, and I don't want to complicate things for you, key elements of equity and also of justice, or principles of justice and tenets of justice that are used to address inequities. For once, you see in the middle of this circle how we are using tenets of justice, such as distributional, which is seeking to make sure that all users are able to more or less equally benefit from the decarbonization of transport and are able to not suffer or to equally distribute the negative impacts of this. In terms of procedural justice, it is important that the needs and priorities of different users of transport and energy systems are considered in the decision-making process. And recognition justice seeks to make sure that historic inequities that have posed some populations in areas where they cannot get access to transport, that these inequities are addressed in order for us to have a more equal distribution of the benefits of the innovations underway. There are other two principles, tenets of justice that are used in the literature, but I won't refer to them here. Suffice to say that whenever we engage in making sure that social equity is embedded in projects, we need to identify underrepresented people and places. We need to create the conditions for them to have the capabilities to access new mobility and energy options, which you see here in Enhance. And then we need to co-develop programs and solutions that consider those different user needs. And we need to evaluate progress in our efforts to transition to a just and clean transportation system through the use of quantitative and qualitative metrics that allow us to evaluate progress performance. Here at the outside of this figure, you can see how some principles of equity are used. For instance, we need to make sure that the new systems are available to different users, that these users can afford them. Then we need to make sure that these communities are able to engage and that due process is considered in addressing their needs. And we need to make sure that we hold decision makers accountable and that intra and intergenerational issues of equity are addressed. Here I am referring again to the key elements of the approach that we are developing in our group to move equity and justice from theory to practice. I'm repeating here the same framework that we are using, and here I am referring to the process that we are suggesting to embed equity in transportation, mobility, and energy projects. As I have indicated before, equity tools can be used as analytic tools. In this case, I want to share with you an example of a tool that we use to identify different groups, socioeconomic status groups in the state of New York. We use a typology analysis of equity and electric vehicle adoption in New York State. Our methods included the scaling and clustering of 17 indicators such as age, education, income, access to roads, and also other social and built environment characteristics. We then clustered them and created 5 clusters that you see here. No, 4 clusters in this application. We found that the adoption of electric vehicles is highest in educated and high-income core and suburban areas, which you have here in red and in this kind of purple color. And it is lowest in rural areas, which is understandable because that's the way the built environment works. But we also found lower levels of EV adoption among urban low-income areas, which are here in this little turquoise color. Why? Because it is difficult, even though the prices of electric vehicles have decreased, it is still difficult for these populations to afford the higher upfront EV costs of buying a new vehicle. The impact of this kind of approaches is that analytic tools is that they provide higher resolution data that are more useful for solutions tailored to underrepresented communities. For instance, we were able to suggest that the use of electric carpooling is more appropriate for rural areas. And again, so we need to tailor the solutions to the different needs of representative sectors or socioeconomic status sectors of the population. As I already had indicated, equity tools or energy justice or tools can be also used to monitor progress in policy making. In this case, I am including here examples of energy transition metrics guided by energy justice principles. You see here on the first column the energy justice tenet that was already described in the prior figure. You also see the applied principle, and then based on this, the policy sub-priority, and at the end, in the right column, the metric we use to measure this. Let's pick one example for each of the tenets and principles. Let's start with distributional equity. A key element of achieving distributional equity is to make sure that different sectors of the population are able to afford these new technologies. So also important is the fact that if we transition to a different transportation or energy system, that the workforce affected by that transition is able to be employed in the new economic sectors. Therefore, for instance, a key metric in terms of workforce development is to make sure that we are completing the job training or other workforce development program, that the proportion of housing units classified as affordable increases, because access to housing is a key element that we are connecting here to transportation. Access to affordable housing and transportation is a key mean to achieve distributional justice. Let's now consider procedural equity. Remember, here we are talking about making sure that the needs of different users, from the rich to the poor, are considered in decision making. So we have some metrics, for instance, participation in decision making committees, direct community relationships created. In this case, what is important is to make sure that we go beyond consultation to really embody the needs and priorities of different communities in our policies seeking to transition away from our current systems. Then let's focus on intra and intergeneration equity. Again, here we are considering that whenever we create a new economy, one that is based on wind or on solar or on electric vehicles, we are able to develop workforce development programs, to cultivate business innovation, to train the workforce in order for people to be able to be employed in the new economy. So these are, again, some examples, but what is important is to understand, based on these two examples, that there are already tools that have been embedded and related to the energy and transportation transition programs many countries are involved in currently. I would like to close this presentation with a program that, together with Sangini, we are developing. It's the Global Consortium for Sustainable Electric Mobility buildings, and grid integration. This program, we are already piloting this program in Latin America and Asia, and our vision is to have a world where widespread integration of electromobility with advanced grids and buildings energy systems contribute to decarbonized and socially inclusive energy systems. So we want to accelerate this transition by engaging with different stakeholders, practitioners, and experts in efforts seeking to really address key elements of the links between electric mobility, the built environment, and the grid, to develop zero-emission societies, and to provide technical assistance that deals with key elements of this transition, not only technological elements, but also standards, investment portfolios, business development options, and any other options. So again, feel free to connect with us, and because this is one of the examples of the work we are embarking on. This is all. I would like to thank you for the opportunity to present our work. Please feel free to contact me if you have further questions. Most importantly, please feel free to contact Sanjini Nanayakara and or Isabel McCain if you have further questions. Thanks again, and I'm looking forward to staying in touch with you.